month meetup, but we'll see if it works out. It's maybe normally we do every 2 months, right? But sometimes we sneak in a couple of meetups here and there. So we schedule the meetup here for every month. We'll see if it works out. But stay tuned for the next one, which is February 27th. And we'll post it in the meetup group. Sponsor IBM for today. And we have live streaming going on. That works for us. And of course, our panelist here, our moderator, he'll introduce to all of them. And thanks for coming here and joining us. Then I'll introduce Mike Hollinger. He has been very supportive of our meetup. He actually gave a presentation to our meetup some time back, and he's the chief architect for machine vision in IBM cognitive system, and he has been leading a very big group in power system. He's a master inventor, and while he's not doing all this cool stuff, he's also an avid runner and also a great cook. So with that, I will hand over the mic, and hopefully we'll hear about the other panelists here, and we'll go from there. Thank you.
Thanks, Tuheen. I appreciate it. So if you go back. Perfect. So it's my pleasure to help kick off this meetup, and thank you all so much for coming. We hope to have a really interesting conversation. We hope to create some interesting thoughts and solicit some questions from you as well. So this should be very much a conversation that we'll go through in the next hour or so. I want to just take you through a couple of really just basic logistical things. We're going to go through a couple of topics today. We'll talk about really 4 different things in about 15 minutes each. We'll have a retrospective on what's changed in the last year or so in the area of AI, focusing on computer vision and text analytics in particular, as well as infrastructure and how it's actually going out into the marketplace. We'll talk about the current challenges with all that, because there's lots of cool stuff that you can do, but lots of hard things you have to do to get there. And talk about the future direction, and then open up for questions from everyone else here. So please, as we're going through this, if you hear something interesting and you want to dive deeper into that, we'll have time set aside in the last 15 minutes to go into those topics and allow for that dialogue. And of course, because this is a meetup, we'll be able to talk afterward as well. So I want to go through and introduce everybody. To my left is Predrag Jirovec, who's a senior R&D engineer for Power AI Vision and IBM Cognitive Systems. Predrag is currently working on deep learning models for intelligent computer vision, and specifically focusing on object detection, classification, segmentation, and action or activity recognition. These are in the spaces of manufacturing, safety, medical, or automotive applications. Some of those prior experiences include perceptual video quality analytics and 3D computer vision and classical neural networks. To his left is Jason Furmanek, also from IBM. Jason's the design and development lead for Watson Machine Learning Community Edition, which is IBM's distro for AI packages and frameworks. He focuses on maximizing consumability of these important software ecosystems for both x86 and PowerPC 64. Jason's been with various parts of IBM over his career, longer than me actually, for over 19 years. And some of his previous roles include working on OpenGL library programming, video encode decode, and he's even had some client-facing roles. Time away from work spent with his family, often traveling. To his left is Carl Weinmeister, who's Cloud AI Advocacy Manager at Google. He leads a team of data science experts to develop content and engage with communities worldwide. Carl has worked extensively in machine learning and cloud, and he was a contributor, in fact, to one of the first AI-based crossword puzzles solvers that's still referenced today. And for those of you who are following along, if you want to Google proverb, you can go look that up. And then finally, to his left is Josh Brown, who's Chief Technology Officer for Narrative DX, which is actually a alum or graduate, I guess, of Capital Factory. I forget the term. At Narrative, Josh oversees all development and research of their NLP text analytics platform. Narrative specializes in patient experience comment analysis and provides actionable insights to hospital systems to improve patient experiences and ultimately improve patient care. We're going to dive a little bit deeper into that here in the first question. Prior to working at Narrative, Josh actually had a fairly exhaustive industry experience in the video game industry, where he worked on some of the largest releases in the last decade, and as well as working in the defense industry, working on numerous DARPA projects. So, Josh, I want to leap into it actually and kind of go and start talking about the patient experience because that's a big part, literally a part of the core element of the company. So, Narrative really helps improve patient experience through AI. So what sort of challenges have you faced as you've been working with real life actual data sets?
Yeah, thanks, Mike. Yeah, thanks, Mike. To get right into that question, I think the hardest part about applying AI in healthcare, and this applies, I think, to most domains, but it's really specifically in healthcare, is there's very, very little room for error. So when we talk about having F1 scores and accuracies in like 95th percentile, like that's not good enough. We can't walk into a doctor's office and say, hey, we can detect this patient having this problem 95% of the time. They'll just laugh at us. And quite honestly, actually laugh at us. So we have to be very exacting. We have to really apply really high levels of diligence to what we roll out and what we put towards our clients. One thing that's really frustrating is we can be very accurate, but when we get something wrong, and you guys, I'm sure, have the similar problems, sometimes they're wrong in like hilariously bad ways, and that's where we get in trouble. So in text analytics, one really hard problem is sarcasm. Right? So if you leave a comment for a doctor and say, you're terrible, I hated everything about it, thanks for killing my mom. Well, the thanks for killing my mom part might come through as a positive comment about the doctor, right? Depending on how you trained your models and stuff. So we have to be really careful about sort of our training data and the problems that we see coming out of sort of biases in data. So I think that's sort of the biggest thing that makes healthcare specifically and what we do hard.
So actually, Frederick, as a follow-up to that, right? Computer vision, literally because everyone can see it, is really almost synonymous with AI, to the point where my mom sees something in a movie and asks, "Is that what you do?" And we have to have that conversation. And sometimes it's actually, yeah, maybe, if it works. Looking back, where have you seen the investments kind of moving in the field in the last year or so?
Well, out of the things that we actually focus on, and that's basically in training of vision models. So we focus both on data set preparation, the training, the inference and deployment. If you look at those segments that way, there's a lot of startups that are actually doing labeling now and focus on labeling. Labeling is actually a huge problem because some manual intensive, and errors are kind of subjective really between different labelers. So there's, as I see, a lot of these startups that are either investing in the tools in improving the labeling experience and accuracy. In training, of course, it's again different fields. Whether it's automotive or medical or other fields that are media. So different companies kind of have a niche in terms of having a very good model and kind of get the VC support for it. So there's theoretical part, there's practical. A lot of interesting models are happening in not just object detection and classification, which is kind of the more classical deep computer vision, but things like action and activity detection, 3D object recognition, prediction actually into the future, what's going to happen. And then in the inference / deployment, it's a lot of companies, particularly smaller companies that often get acquired by the bigger ones, doing specialized ASICs and FPGAs that actually have this very efficient flow of kernels and making the flow both energy and efficient and as well as fast and small. So it's like in all these 3 or 4 areas, how the data flows through. You can see different companies kind of popping, or bigger companies actually acquiring these smaller ones that have an interesting idea.
Cool. So if we look at actually the area of NLP actually in particular, I might ask Carl, you've obviously worked with a variety of different companies in different industries over time. Where are the best use cases, and where are you seeing a really great fit, and where are you seeing things that maybe aren't a good fit?
Yeah. So speaking of NLP, we talked about images. Now let's talk about text a little bit. It seems like for each different data type, there's sort of a type of model that seems to work best. With imagery, we're seeing like CNNs or convolutional neural networks. In NLP, recurrent neural networks are the type where they're kind of strung together was state of the art. But in the last, couple years, there's been new techniques. There was, Google had this BERT framework that was open sourced, and that's really changed a lot of things. And it has a very different architecture. It sort of has this, encoder decoder style where it kind of takes some text and it sort of goes through the neural network and sort of condenses it, and then it comes back out in the decoding part. And if you think about it, that's how you can do things like document summarization, right? Where you can say, let's review an article and then give a 1 sentence, maybe a summary of what was in that article. So what we kind of think of as text generation, things like that. This BERT model does very well. So, it's really cool, all the advances we're seeing, like, and not trying to be an advertiser for Google stuff, but like, for example, in, Gmail and things like that, I'm amazed by how, integrating that into some of the products, it's just complete. It used to be there's autocomplete of a word. Now it's almost like it knows what you're thinking, just that, and maybe the things I think are pretty basic. It kind of knows what, what I'm thinking. But I just really think in a lot of ways it's, a lot of things are changing in NLP. And I think like with unstructured data, it's very difficult to deal with. You need a lot more processing power. And we're also seeing some new architectures that make it easier to use on smaller chips. So there was another announcement that happened, I think it was a couple weeks ago. It's called Reformer. So there was a transformer was sort of the architecture that BERT was based on, and it required these massive number of TPUs, these tensor processing units, specialized chips for machine learning. And it wasn't really accessible to, most folks. So Reformer kind of looked at how do we sort of take the best of that and optimize it so you could run it on a GPU chip. And that apparently worked very well, got really close results. So I think in this industry, we kind of see where you have researchers work on huge amounts of hardware and kind of test the limits. And then we kind of see people come in, how can we maybe reduce a layer here that we don't need, cache this, throw away that, and really shrink it. So, things in image recognition, we had things like, Inception and all these other networks, and now we have like SqueezeNet and MobileNet and all these architectures that fit on a chip. So it's really, anyway, pretty cool. In NLP, I think we're starting to see that it'll become a lot more available to everyone soon.
Actually, I have a quick question for the audience. Who here has checked in code into a source repository somewhere in the last week? That's a different question from who's written code, I'll note. Okay, so then to ask a different question, when we just rattled off MobileNet, SqueezeNet, Inception, and so on and so forth, who here knows what those things are? A few folks. All right. So we're gonna have to talk about this a little more, right? So like in terms of the advancements of AI, right? AI is not just AI. AI is the appliance of certain software techniques and hardware techniques to go solve a problem or to go produce some answer. So if you talk a little more about what BERT actually is, and like you said, for example, the new improvements that Google has put out, right? So what's really happening? Like what really is going on when we say, you know, take a paragraph and produce a sentiment of yep or nope?
Yeah, yeah. So yeah, great question. Maybe I kind of jumped into some of the acronyms and things. Yeah, so just as an example, there's a good article from the Google search team about using BERT in Google search, and they said this was the biggest improvement to the search engine in 5 years. And the reason was that, you know, when you enter queries in it, you can ask in a more sort of natural language kind of way. You don't have to enter keywords, and kind of back to kind of, you know, BERT versus the older approaches. So the older approaches kind of had a very a sort of a linear left to right or right to left kind of view on things. So just depending on the way you structure your sentence, you know, it's going to understand it well or not well, right? Where BERT, its whole thing, BERT standing for like bidirectional representation. It's sort of looking from both sides, and really gets a lot better, you know, accuracy when you're trying to understand text. And you know, it's kind of amazing. In the keynote that Jeff Dean did at Google, he talked about there was some text that was talking about what airplane mode is on your cell phone. Like, oh, airplane mode is when, you know, you can't, you know, access the internet, blah, 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 blah. And it was like 2 paragraphs. And, you know, the computer, you know, they asked the network, so can you get internet when you're in airplane mode? And it just says no. Like, it literally understood that whole text, absorbed it. And that's really what, that's a, you know, there's a lot of different like tasks in when they talk about natural language processing. That's one of them. It's like answering questions. And that's pretty cool. I mentioned another one that's sort of the, there's document summarization. So kind of like understanding what's in a document. Another one's classification. So that kind of applies whether it's images or not. You know, given this piece of text, what is it? Is it a, you could think about like a workflow, like in a business, like I have legal documents of different types or financial documents, and I want to get them routed to the right place, or emails that are coming into customer service. How can we kind of quickly scan that and take a good first guess at which channel it belongs to? So lots of ways that, you know, it's helping consumers and businesses.
Can I jump on that?
Yeah.
Absolutely. Yeah. So at Narrative DX, we process unstructured text that comes from patients, and we use BERT specifically for sentiment analysis. You know, so positive, negative analysis. And pre-BERT, we had a huge amount of research, 4 years worth, where we developed something like 6 different models for different types of text that would come in based on how structured it was and what it was, where data source, and a variety of things. And BERT came in and beat all of it. So it was, for us, it was hugely revolutionary in terms of where we put our efforts, because that freed us up to focus on other hard problems in classification and other things. So for us, that step was huge. And from the computing side, like Carl was talking about, it freed up a lot of our resources too. So it's a big win.
There's some flavors of BERT. Do you guys? Sorry, did you do you guys customize BERT, or do you guys use the big full implementation, customize it a bit?
We did, yeah.
That's interesting.
Yeah.
Cool.
Yeah. Actually, just for a couple of reasons. One, because we're sort of we like to tinker, I guess.
Yeah. Well, you got to fit for your workload, right? Of course.
Right. Yeah. And part of it was too, we weren't sure how well it would work, right? So from the beginning, so we wanted to play around with a couple of different ways of doing things.
Very cool.
So Jason, actually, since you have the mic,
I have the mic.
So are you guys okay if I project rather than doing the mic thing? Okay,
Sure.
thank you. So you know, that's a really interesting kind of segue, right? Because there's a boundary where there's the AI problem of how do I understand the sentiment of this text, and then there's also the kind of classical programming or the rest of it, right? The actual software that's around all of that. So, you know, is there a boundary between the two?
Yeah, that's a good question. And these problems that we're talking about, they're very large, they're very difficult problems, right? These models are huge. They're customized. You need to have versions of them. You have lots of data that you train on. You know, what does all that sound like? It sounds like a pretty typical large IT problem, right? Like if you break it down, this is a IT problem at scale. And how do you tackle IT problems at this big, right? You need agile processes, right? You need continuous delivery models. You need structured deployment mechanisms. You need to be able to update these things and have them be stable in production, right? That these, you know, so it is a fine line there, right, between, you know, typical IT, you know, operations, and then, you know, the data scientist, right? So it's
well, you almost described the DevOps flow of sorts.
Right. So I think like in DevOps is relatively new in the IT world, right? In the grand scheme of things, and you know, using the top of the line IT models to be able to actually put this stuff in production and do it correctly, I think is the right way to go. And certainly, you know, having systems at scale will work as well. So I mean, that's depending on, you know, your needs, right? You have to have the hardware to back it up as well. So, yeah. So I think it's an interesting topic, and it's all about discipline in your IT shop.
Right, and like actually, Josh, I mean, you know, you actually kind of touched on it a little bit, I think, but you're using BERT, and you're also playing around, and you said experimenting and trying to see how you can get that extra edge. So, what are the challenges when you go from a Jupyter notebook to something that's in production, right?
Yeah, everything. That's the whole.
That's the trick.
That's the trick, right? So, at Nerdidex we have a team of 8 folks right now, and we're growing a couple more, but really only one data scientist. So we have 7 people that build all of the stuff around our key bit of technology. So, you know, like, and I think that's a fairly, just from knowing a lot of other companies, that's a fairly common ratio of about that much sort of scaffolding that it has to exist in order to do all the things that Jason was talking about, of deploying and keeping versions, and, you know, if there's a problem, being able to diagnose them, you know, what's going on. And, you know, there's just lots of infrastructure management that happens kind of around the key stuff.
Right, there's I think a picture that came out from a paper last year that shows you know, the deep learning model as a box, right? And then there's just blocks surrounding it, and it's this one little thing in the middle of this sea of other components that are necessary to have a piece of software. And I think it's kind of what you're describing, right? There's all this other stuff that has to be in place.
Yep.
So, and Jason, like from your view, you've actually worked on some fairly large deployments.
Yeah.
So when we say large, it's like Summit and Sierra, which are the #1 and #2.
Those are very large. Yeah, they're not all that large.
Also commercial as well, right?
Yeah.
So like, what are you seeing there in terms of challenges, right? Where are people when they go to take something off of a notebook and try to put it out there?
Yeah. So I think it's a good question too. I've heard a lot that, like, a lot of people are dabbling in AI. No enterprises are really doing it yet. I don't think that's accurate. I think people are doing it. They're maybe not doing it on large scales just yet, but all the customers that we've been in and talked to, you know, they're up and going on it. They really are. You know, a lot of times they need help. A lot of times they, you know, could do better, or they're looking for the better accuracy. They're trying to get that edge, right? Trying to, if everybody in the world is using, Inception, right? They wanna have something that's a little bit better, right? And maybe they don't always know how to do that, right? But there are people doing this in real world, things that people don't know. Besides, we know Google is, of course, right? But like, enterprises across the country, right? It's being picked up. It really is. And it's interesting to help with, interesting to be in that industry for it for sure. So.
And I think maybe Carl, you might have an interesting perception or view because you work with clients directly. I think actually we all do, to be honest. But as an advocacy manager, that's part of you're advocating for the client within the enterprise of Google as well, right? So you're kind of going both ways. So what are the inhibitors that folks are having as they're trying to pick up and do stuff? Like as a client who wants to get going, like what is it? Data? Is it the fact they got to go find the model out of the giant zoo that Jason just rattled off? What else is happening?
Yeah, so I think sort of the model part is what gets a lot of attention, but really I don't think that's the stumbling block. Like I think there are a lot of sort of almost like cookie cutter solutions for different problems. There's things like TensorFlow as a hub, or Keras has out of the box models that you can really just import what that sort of semi cutting edge model is, and you don't need to be an ML researcher to reinvent the wheel. And there's a neat paper that talks about it was like the unbelievable effectiveness of data, that the algorithm itself makes a very small difference. It's the amount and quality of data really that's the huge factor that overrides all this sort of fancy stuff when we talk about like what wins in a competition, slightly better than another algorithm. So
you're saying Kaggle does not necessarily
right, yeah. Yeah, so I mean, I think data is basically the biggest thing. A lot of projects, you may not have just basically enough data, the quality data across the number of sources to get the accuracy you need. And sometimes it's like at enterprises, you have to sort of work across different groups. The data isn't there today, but I think that's where the business side comes in. If there's a sponsor, like an executive that can help just really push this and sort of make the different groups talk and sort of bring everybody together, get all the information in one place, it's more likely to succeed. I always think like we talk about being agile is just do a prototype, a POC, see how it goes, and fail fast, fail often kind of thing. And just one quick, with the MLOps, they call it MLOps now, sort of like DevOps applied to ML. I mean, it's super important just because, like, in the example, like the medical industry, it's like, folks that come from a data science background might not have always gone through sort of the path of software engineering where you have your unit tests and you check in your code and you do all these things. Like, hey, I created a model, it's put in production, and what if you make a mistake that puts patients' lives at risk? Like, you have to apply more rigor to your processes around it, and it's kind of a new thing, and you have to kind of have everybody working together.
So for those that might be polishing a resume, MLOps.
Yeah, right. Yeah.
And if you have more than say 2 years of MLOps, then maybe that's probably not.
Right. Yeah. Right. That's a red flag, right? Yeah.
MLOps since the 80s.
Yeah.
But like, it's actually interesting, right? So like, Frederick, like you work with computer vision. Anyone can make a make a model that can detect dogs or cats because there's the.
Can anyone actually do that? Because I don't know.
Anyone can attempt to make one. I'll put it that way. They have the data for it. That's actually a great point, Josh. But like, you can go get data sets that have thousands of images labeled with it, right? So MS Coco is one of those classic ones that everyone uses in the computer vision space. And it has, what, 85 categories of objects labeled or something like that?
81.
So it's interesting that you can go get 100,000 images, but not everyone has 100,000 images of puppies. So
Right.
what do you do when you have 500?
So just a little bit comment on the data set versus model first. I think, when you have a lot of data and you're kind of focusing on very few classes, that's kind of the easier scenario. But and that's, you know, for classification, object detection, which are more classical models. You could say, you know, I can just drag this from a zoo and it'll work. But there's a lot of other places like what we do partially, action activity detection, 3D object detection, 3D stereo reconstruction, a lot of self-driving stuff, a lot of stuff that goes into the cameras now. Those are bespoke models, and they're not really even open source. Those are very sophisticated models. So I think a lot of these competitions are focusing on, you know, inception, DenseNet, you know, all sorts of little tricks. How do you get to that, you know, last 0.5% of you know, topping the previous result? But, you know, in other areas, the models do matter. Like, for example, like action activity detection also uses bidirectional LSTMs and stuff. So there's much more structure to the model. You can't just, you know, play with these smaller, fine tunings of the training of the model. You actually have to come up with a structure that actually matches the problem. So, you know, and kind of going back to your question, then, you know, how do you deal with the data sets that have very few examples, or you have, you know, video footage of driving a car for days and days, and only occasionally you get to a point where there's something interesting. So basically, you know, how do you do outliers? How do you do these very rare but very significant, you know, events, and how do you represent them well in the data set, as well as, you know, for medical or some other critical you know, applications where false positive or false negative is, you know, 1,000 times more, or whatever magnitude of times, is much more important than what you're doing in the rest of the data. So that is kind of boring. So
there's a sense of balance to it.
Yeah, yeah, and, you know, we've been recently dabbling with the you know, few detection model, or learning from a small number of labels, and that is trying to you know, modify some of the classical object detection models to actually be able to learn from very few examples of objects, you know, that appear, that are similar to previous objects but are still new objects, and that actually doesn't require thousands or millions of examples to you know, be able to train a you know, usable model.
Right.
So yeah, some of it is data curation, if you will. Some of it is, you know, what we do also, auto labeling, so trying to kind of automatically label things. That's a lot of stuff that is happening nowadays in the self-driving kind of industry, because the amount of miles that you're producing per day, there's just not that many labelers in the world that can handle that on a daily basis. So you have to come up with these clever techniques, how to extract interesting parts of the video, and how to perhaps auto-label, and only occasionally, you know, have to have a manually, you know, introduce labeling, and that's kind of what's in practice being done nowadays to actually go through these huge data sets.
So Josh, I mean, from the text world, I mean, I was kind of racking my brain trying to come up with an example, but I think in the term coder in this room, that's a different term in the context of where you spend most of your time. So how do you deal with that?
Yeah, so we have to make very keen decisions on where we use machine learning and where we go to some rules-based or some other mechanism for determining categories and things. So like in that case, coder, you know, means someone that is at a hospital that's putting in like what medical code is in, versus many of us in the room being, you know, developers. There's lots of other examples like on some of the data that's been being used to train. So in medical contexts, many instances of our data refers to nurses in the female context, because most nurses are female. And so you have to be very careful about training a model to not know that she could be a doctor, because it turns out if you label things using gender, you can get in trouble. In fact, one of our competitors lost to us in a bake-off specifically on that because they couldn't fix the fact that they kept labeling all she references to nurses. Yeah. So there's lots of gotchas, you know, in sort of data conditioning, and in terms of, we expanded our model recently to include dental practices. Well, people talk about teeth cleaning. Well, all of our stuff for cleaning was about like rooms being dirty and the janitor's not coming around, and so suddenly we had a bunch of new data that came in that didn't capture that at all. So there's lots of little things that come along that, you know, like we were talking about with the edge cases and the infrequent things.
So, I mean, so Carl, actually on that topic, right, because we're getting into kind of the ethics and the fairness and that kind of stuff. I mean, explainability is kind of the subject of what we're talking about, right? It's trying to be able to articulate what's really happening. So how do you see the industry kind of providing tools to help clients understand what's happening in the area?
Yeah, so models, you know, used to be simpler, you know, with things like, you know, if you did a linear regression, you know, you'd literally know what were the factors in the model. You know, this variable had this coefficient and I got to this result. When you get to things like neural networks, where it's, you know, these crazy number of layers and nodes, that sort of knowing what's happening is pretty difficult. However, those models are way more accurate. So you sort of had this trade-off between explainability and accuracy. And now when certain tasks you can really only do with neural networks, like, you know, image, you know, recognition and things like that, you really need explainability. So explainability, there's a number of tools that have continued to be refined. It's been this technique has been around for a while. So sort of you kind of look at a individual prediction and you kind of play with the features that are in that. You know, what if I take it out? What if I add it back in? How much difference did it make? So you're kind of indirectly figuring out how important the different things are.
So you're saying if I take the input, I kind of fuzz up like some aspect of the input, some element of like a person's age or zip code or some such.
Right. Yeah. If you had a model that had 10 different, you know, features, take age as being one of those, for instance, and you remove that variable, you saw how was the accuracy, you add it back in, you kind of look at the delta. I'm simplifying a little bit, but and then you kind of do that across the whole data set. You kind of have a view across all the data. What were the most important things? And that has a lot of benefits. Like one is it can, just from a model sort of efficiency perspective, you can look at what are the things that didn't really make a difference and simplify my model and kind of remove them. And then also, you know, back to kind of fairness is, you know, what you can do is kind of look at, let's slice the data different ways and make sure that we're getting similar error rates when we look at the different, you know, subgroups that are part of this model to make sure everybody gets the same experience. And, you know, kind of really the root cause is, you know, starting with the right data, enough data that represents, you know, everyone and everything that's going to be part of your model in the right proportions. That testing is sort of on the back end to sort of see, you know, once I slice it different ways, what are the results? Do I need to maybe include more data of different kinds to kind of help with that? So yeah, there's a lot of tools out. There's, you know, frameworks to do that. And there's also now some tools like model analysis. There's something called the what if tool where you can kind of put your model in and get a visual of all the different data points and kind of see why things did what they did. So, yeah.
Awesome, thanks. So for the audience, I want to say, you know, we're going to have about a couple more questions and then we'll go to your questions. So be thinking of stuff. I want to switch gears and look a little bit about where things are going, because we've talked a little bit about where we came from over the last year or so, what the challenges are. Now I want to look a little forward on what's going to change in the 20s now that we're in the 20s. It's just kind of weird. Yeah.
Yeah.
Yeah. I've seen so many roaring 20s parties. We're going to have to get past that one. So, Jason, since we kind of talked a little bit about it, but, are we going to see more specialized hardware and software? Is there room for this for other folks to go contribute beyond just the data scientist?
Yeah, there's lots of AI hardware startups right now, and there's some that are getting bought for lots and lots of money by big companies. That it just shows you right there, it's a hot industry right now. So, right, because really, if we look at this AI boom, it's almost it happened at the same time as kind of this parallel computing boom, right? It's like NVIDIA hit with their GPUs that could do some of these jobs really, really fast, and then all of a sudden the state of the art start going like this, and then it feeds back into the hardware, and so the two booms there are intertwined in a lot of ways, right? So and a lot of people we want in on that. What they think they can maybe do something a little bit different. Could we is there other ways of tackling this other than massive floating point, for example, right? Is there different aspects of that we're overlooking, right? And this is just kind of how these cycles work, really, on the hardware side and like the state of the art on these models, right? Like when we talk about BERT, it seems like it's this overnight success, but it really kind of wasn't either, right? It was iterated on some earlier kind of concepts, and they put together, and then bam, it's on fire, right? So it's I think there absolutely will be some new accelerators hitting the market that everybody will want to try out for sure. The frameworks, both like the two big frameworks, PyTorch and TensorFlow, are tooling under the covers to try and make it easier for people to add these accelerators as well. They're adding in these intermediate representation kind of steps, so then you can plug in your own custom compiler in there as well, a lot easier, right? So the TensorFlow itself will compile down to this certain kind of IR, and then a lot easier for custom hardware just to plug into that, as long as they speak that language, right? So you won't have to plumb through the entire framework of TensorFlow just because you wanted to add a custom chip, right? So that type of thing, and PyTorch is doing something very similar. That type of thing will make it a lot easier to proliferate these, right? They won't have to spend a year and a half trying to add your stuff into TensorFlow, which companies have tried and failed to do. So it'll all kind of come together, and we'll kind of see how it goes. But so I think it's a space to watch, and we'll see if we get some cool stuff.
Yeah, Jason was saying, some of the things are coming together. A lot of these theoretical things that were, how do you prune the network, how do you, aggregate the layers and stuff like that, is now actually making it into compilers and directly into the, bespoke hardware. And a lot of these applications, such as cameras, basically nowadays, which is now all about computational photography,
big in the
is all
edge,
AI and all bespoke chips and models inside of them. And of course, the self-driving, which is showing many companies doing their own bespoke chips that are even more optimized than what you can get on a classical GPU. Both Tesla and Mobileye and the others are doing their very sophisticated chips that are optimized for the workflow that they have.
Actually, you kind of blew by it just in that off-the-cuff comment, but you mentioned the edge.
Yeah.
Right?
Yeah. That's
one,
right.
define the edge, and then two, because I think every time it changes, but
sure.
But how does the edge change things for AI?
Oh, that's a great question. So edge, what I mean by edge, when I made my little comment there, is non-data center stuff, right? So it's like out on the cameras of the world, out on the edges of these large network data centers and things, where you can actually kind of do the inferencing right there, right, and get the benefit of it, or on your phone, right, too, of course. So how does that change, right? Having inferencing of an AI model in your pocket that can do things that a supercomputer couldn't do even 5 years ago or whatever, right, is just groundbreaking, right? It's like the things we'll be able to do, right? If the things handheld devices and medical use cases we'll be able to do shortly is going to change the world, absolutely, right? So.
Right, and in fact, like I think like the portrait mode in my shiny new phone, or it's not so new anymore, is using a neural net to help detect me when I'm using the non-stereo camera, right? So if you look closely, I think if you look closely on an iPhone XR, which only has the one lens, not two or three, you can see a little tiny line around me because it found me, extracted me, and fuzzed up artificially the stuff behind me. So you see these really interesting enablement things that are going to happen. Has anyone played with an NVIDIA Jetson Nano device? It's like $100, or actually less now. Like they're great things. They're little quad core, 4 gig RAM, gigabit Ethernet, and a GPU, and you can run a pretty interesting model on it on your desk. It might require a beefy little USB power supply, but runs on a USB power supply. You know, you can run on battery if you want to. So, in, like, you know, if you look at it, I'll just kind of put it out there, right? Like, we hear all these things in terms of edge compute, and this is kind of my last question before we go to the audience. We hear about edge compute and AI and all this stuff, and companies are investing in AI. But then if I go out and look, I'm sure find an article written today that said we're approaching the AI winter. So what is it? Which is it? Anyone want to answer? It doesn't matter.
I mentioned a minute ago that the AI boom and the parallel computing boom are kind of linked, right? So, and I don't know. I'm assuming in my opinion, it's going to boom for longer because there's lots more that can happen there. But like if the hardware hits the wall, it has a chance of having the research into AI hit a wall a little bit. That's kind of what happened back in the 80s or 60s, even when they first kind of invented a neural network. It's like, this is great, but like, we don't really have much to actually do with it right yet. So there may be a point where like we have some new kind of things we want to do, we just don't have the hardware to do it, or it kind of hits the wall. But as far as like, okay, it's impending doom on AI because it's been burning so hot, I don't see it yet.
I almost see it to the opposite. I almost feel like the models are very too specific almost for their use, and for advancing things further, you will need more general AI basically, and that's where the models are just not there, and probably won't be there for a while. So I think for some very specific usages, the hardware is actually kind of there, the models are kind of there, but when you're trying to fix that 0.5% left, you still have 90% work to do, and that's very evident like in many fields. Self-driving, you have to have some context understanding, like we do humans, and stuff. And you were mentioning the speech and these nuances that seem like you need much more complex models to figure out that very small left unknown there.
I think that I sort of see it right in the middle of both of those. I think there's a lot of little problems that we can apply things to that people haven't got quite there yet. So there's a lot of small problems. We'll slowly work through those, and then when we get there, there'll have to be another leap somehow. But for now, I think we're going to see sort of a steady march of new technologies that come along that solve some narrow problem in some better way than we can solve it today, and we'll slowly move along until sort of we reach the limit of what kind of our current modeling techniques can handle.
Yeah, and I think we've kind of thrown around a few keywords here, right? Like narrow and things like that. And if you've maybe heard those terms, like some people group AI into this ANI and AGI, the narrow intelligence and general intelligence. So the narrow being certain tasks that a computer can just do insanely well, and recognizing an image. And we kind of have passed thresholds where many of these tasks computers can do better. But then there's like when we talk AGI, which is what you kind of see more in the movies and media, that those advances just haven't quite been made yet. The example of like not detecting sarcasm or things that babies can do that computers can't yet. We really the research hasn't crossed into that. But in sort of the narrow, very specialized tasks, just like some examples of, working with customers where like, say they're on the edges of using AI, and I look at AI, it's not magic or machine learning. It's really just normal, like, or everyday software development is you're writing rules, if this, then else, where machine learning is inferring what those rules are, looking at data and just saying, okay, well, I see those are the rules based on the data that I saw. And so it's just a more dynamic, robust way of creating a system, right? That's really all it is. So I think we're seeing companies that are using AI in new ways, and like a lot of these little things are starting to get picked off, but there's a long ways. Like, say power companies where they're looking at how do we predict power outages, and that could be looking at historical data. It could be like bringing imagery in. How do I look at, where the trees are close to the power line? You get into image models. Like across every industry, they're starting to look at new ways to sort of pull AI in. And I think it's going to become now, again, do we get into sort of those Terminator, this kind of AGI stuff? I don't know if some people say it'll take 50 years or I don't know. But.
So you're saying Siri is not a general intelligence? I said that I was hoping you would chirp at me, and I didn't say hey first, so we learned that. So hey, that's a good segue to kind of turn to audience questions. So hey, a hand went up. That's go for it.
So where do you see reinforcement and deep reinforcement learning today? Where do you see it in the near future? And are any of you guys doing anything with it?
I can take that. So deep reinforcement learning actually is pretty complex in a sense that while you're modeling nonlinearity, the interaction between you acting on a world and how it reacts to you and how your data set actually changes over time based on how your policy changes over time. There's a lot of tricks you have to do in the deep learning to actually even make it learn. And even now, even with Google Mind having some success with video games playing and stuff, the reinforcement learning is still not at a point where it is practical for physical systems. So you can do a lot of simulations still with gaming and other simulated like game AI and stuff like that. But this part that I kind of mentioned with the context and with the general AI, where the model can actually generalize things and actually learn from very few examples, that's still years and years away, most likely. So again, the deep learning or the modeling part, where you're not using tables and other structures, that is, kind of solved with the deep learning models. But the part where it's able to generalize and kind of extract this more general knowledge and policy for it, it's still not there. Things have still not moved to a practical level. They're good for, as I said, gaming and places where you can simulate it many times without anything breaking, but it's still not there. The algorithms are still not there where you can actually take that and use it on a physical robot. And and things like the Boston Dynamics and all the robots, that the phenomenon in terms of dexterity, that's a lot of that is still predictive control. It's still not using reinforcement learning to actually try this million times.
Those are the robots that I think the most recent one that I saw was a pair of them opening a door, holding the door, and walking through the door.
Yeah, and doing jumps and flips and all sorts of things. But again, it's still done. I think most of it is actually predictive control, classical control.
At IBM, are you waiting for the next bird, or are you creating the next bird? It sounds like you're waiting for the next bird with your answer on deep learning.
Well, no, this was in context of deep learning, in reinforcement learning. We are actually doing a lot of stuff in image and video, action detection, soon 3D and stuff. So, but your question was, I think, on reinforcement learning, which is slightly different context there, slightly different set of problems.
So my question is about AI ethics. And with the proliferation of machine learning systems, there's been a lot more attention on fairness considerations. And I think IBM has been a leader in terms of putting out some tools in this regard. And so I guess I have two questions. One is, to what extent are those considerations affecting your day-to-day? And then how do you see those types of considerations affecting the future of AI in your respective domains?
I can start. I think you probably want to take this one too. But you're absolutely right. And in my opinion, like, fairness isn't like optional. Like, you're not doing it right if you don't have an eye on fairness, right? And we talked about the explainability. That's part of it. That's just part of it, though, right? And I think it was best illustrated by his use case over here, where the doctors were assumed to be males and the nurses were assumed to be females, right? That's discrimination. Just look it up in the textbook, right? Obviously we got to avoid that, right? So IBM, we're a large company, but yeah, we've at least a few of the toolkits that we've done around fairness. We've got this AIX 360 and AIF 360. These are fairness and explainability toolkits. They work with TensorFlow and scikit-learn. So those we put a lot of research into those, and they're still getting developed. Those coming out of the research. So, and the product that I work on, which is the Watson Machine Learning Community Edition, it's not a research thing; it's a production thing. Where we have versions of those that we're including in there as well. So, but
yeah. I mean, I'll kind of just echo that. I mean, I think we at InterDX, like, it's sort of always. Like, I don't think there's ever like an instance where we're like focused on fixing like a fairness problem necessarily. It's just always something we have to be aware of, kind of at all times. So every iteration of a model, or even in our rules-based systems, where we have to be very careful about kind of any sort of bias that we're going to introduce. It's just something that at least we sort of baked into our entire process, and so we don't have to worry about it on a case-by-case basis. But and luckily for us, our competitors didn't. So, yeah.
Sure. Yeah, how is quantum computing advancing AI?
Well, I mean, it's, I guess, once they have enough bits that they can use, maybe it will be usable for more complex problems. I mean, for now, it's really used more for parallel search, if you will, in problems that are containable in a small number of bits, or qubits, or as they're called. So it's kind of hard to see how fast that will advance, where you can have a bigger model that can actually, for example, do parallel million reinforcement learnings at once, right? It can solve a problem within, seconds or so. So I think the representations of the problems are fixed to whatever the number of qubits is now, like 50 or so. And,
Yeah, it's 50.
Are the problems unique that are good for quantum computing to solve?
yeah, like encoding, decoding, decryption, right? Those are pretty good problems.
Yeah, it's really interesting.
Search.
I'll add a little bit, just because we talked about compute styles, right? There's this idea of heterogeneous compute, and what I mean by that is not traditional. Oh, that's fine.
Okay.
Yeah. Not traditional von Neumann compute with like fetch, decode, execute, store. So if you've ever done computer architecture class, is those things. There's memory models, there's orders and stuff, but that's pretty much it. Generally, parallel is what you see with the GPUs and with tensor processing units. And quantum is fundamentally setting up problem states and trying to ask one, the correct question, and two, get an interesting enough answer that's correct most of the time that you can take as a use for that. So generally those things are going to come around, and I think there's even analog compute as kind of an extension of the massive parallel thing. But the connection of quantum and AI stuff is just something that like is going to be something, but I think as an industry, because I was looking at stuff a little earlier, it's hard to see where there's going to be the interception point or when that will be, really.
Two quick questions. One, where y'all see machine learning AI really integrating with VR in the most interesting ways, and then two, I'm curious where Debater's at, and if it has debated itself, and if so, do y'all have any estimations of what magnitude of time it could do so?
Okay. So,
Second was just curiosity, you don't have to answer, but.
you want to take the first one?
So I mean, the VR and AR in a sense of, you know, or overlaying your object detection and other pieces of information that you either observe locally or it comes from the cloud and it tells you more things, and then you're kind of overlaying that visually, for example, over what you see in front of you. I mean, that's kind of already happening, really. I didn't quite understand the second question about debaters. Didn't quite.
Oh yeah.
get that.
So so for everyone,
Or maybe somebody else wants.
Yeah. If you want to answer.
Yeah, I don't know the answer now.
So Debater is one of the grand challenge projects that IBM has. If y'all recall, a long time ago, there was the Kasparov versus the machine thing with chess, Deep Blue. That was a massive, I think, FPGA and then an ASIC that they built, then a bunch of them in a supercomputer kind of design. There was Jeopardy, which a few of us in the room had the pleasure of working on with the original Watson versus the Jeopardy Grand Masters at the time, I think. And then now there's Debater, which is the idea of being able to argue for or against in a formal debate setting a particular topic. So given no internet connection, can I construct a logical argument, respond to my adversary's argument, and then convince an audience and actually win or lose the debate? So I actually was trying to find if there's been tests of it versus itself. I don't know. I can't find anything.
I know they're using it quite a bit in reinforcement learning when they're doing games, right? They're kind of playing each other, like poker and stuff. I mean, some of them really, and then I forgot what it's called, Go, I think.
Yeah, AlphaGo. Yeah.
You know, that's actually
which is
playing
a great Google
first
project,
learning
right?
from you know, real games, and then learning against each other, against itself, really.
Right.
So you know, kind of that level of learning.
Other questions?
So just curious if there's, do you have any thoughts on progress in AI for content creation? So take two use cases. One would be transforming one format of text into a different one. And then the second one, which is more interesting, is transforming text into imagery. Do you have any updates, anything interesting you see that happening?
Well, so on the tech side, we actually just were playing around with a little bit of text generation when we have our annotated data sets that we train against, and so the larger those can be, the better. So if there's automatic ways to generate text that we can guarantee is labeled correctly, then that gives us a much bigger training model to run against, right? And so we've been playing around with a couple of ideas with that. Nothing that we've been able to productionize, but it's certainly an area of active research trying to figure out, I mean, specifically on the training labeling side, could be a huge win.
So on the image and video you know, it's really not content. It's really, you know, with the GANs, you're kind of creating you know,
the generative networks,
but looking natural content that's kind of happening in the visual kind of domain. And you know, aside from what you see on the internet all these deep fakes and stuff like that. That's okay, kind of the more not cool part of it, but the cool part of it is generating and augmenting your data so that your training can be done not through physical execution but through simulations. And you can see pretty good examples, like NVIDIA did some, for their self-driving program, they did videos that can generate snow basically out of a dry.
So you're saying there's
so it's like generating augmented data for the purpose of training later for better training.
So like given today's beautiful sunny day, I could generate a fall scene, a snowy scene,
Something like that.
Oh,
Yep.
so we can see what Austin's Armageddon will look like.
Yeah, something like that. and for it to be natural enough that actually is meaningful for training. You don't want to generate something that's totally artificial and
Right.
will never happen, and then you're kind of faking your network
Interesting.
training. But it's close enough, when you look at optically, that it's almost like real.
Kind of a similar use case. If you go to that blog post about that reformer architecture, they have a link to a Colab notebook that generates images from like half an image, right? So it might show like a cat where their face is sort of clipped off, and then you'll just see the bottom half. Just you're like, wow, that looks like, and there's even details, where they're sitting or whatever. How it comes up with that, I have no idea. Yeah.
So we have 2 more questions.
So you talk about BERT. So actually there's things more than BERT right now, like Rebecca and Leaps this year they have a new algorithm better than even Rebecca. So I want to know what is the Google next round about the BERT thing. And the second question is Google Health. Maybe I don't know whether IBM is working on the healthcare. So every company now is working on the healthcare. So I want to know what is Google. Yeah, Google Health use like you have Google Health. Like actually, we one of the faculty from UT, Delmed, has become Google chief health officer. So I want to know. So if you can share more information about Google Health, that would be nice.
Okay. So I'm, I'm not in research. I'm not on, knowing sort of the latest stuff there. I do know that, you kind of mentioned there's a lot of extensions to BERT where, training it, there's like BioBERT. I don't know if you happen to use that, right. So I mean, I think BERT I think it came out in 2018, so it's not the latest, but yeah, I don't have a lot of more specifics on the very latest research on that. And then, Google Health, it's kind of about, applying a lot of the, sort of these techniques to solve healthcare problems. Like one of the use cases that we talk about is like the diabetic retinopathy, basically a very preventable disease that with computer vision, you can really prevent a lot of folks from going blind. Just thinking about ways that we can apply this technology for healthcare. So,
yeah, cool. And our last question. Anyone? Very, very back.
Is Google ever hire anybody that doesn't have a college degree, a resume, a copy of their birth certificate, and not a copy of their ID, because these aren't things that everyone in America can have. And it's confusing because even though I do have the ability to get all 4 of these things, it's absolutely discrimination that you're not interested to hire people that actually cannot get all 4 of these things. So I was just curious if they do ever hire people that do not have these 4 things in America, if I'm legally able to work in America.
yeah, I'm not with HR, just a technical person, but like, let's talk afterwards and kind of understand. Yeah, I'm saying I'm not in HR. I don't.
Yeah.
I mean, maybe any general thoughts with other companies or.
How do you leverage transfer learning in your environment?
At least for the visual networks, we typically, all these models already have a base core model, whether it's ResNet 50, VGG 16. So there's already a little bit of a transfer through having the core part of the network already be pre-trained, if you will. But then you can train even the network that has been trained on a previous set further on a bigger set, or add more classes, or not to drop everything and kind of start from scratch. It's kind of this kind of net.
Like an object-oriented concept where you have a supermodel and then you have multiple layers.
No, you could just take.
More specialization.
Yeah, I mean you can do that. I mean you can start with a model that basically trains on a certain number of labels, and then further specify the labels. So basically you had a dog, but now you have the breeds inside. So it did already learn the basic filters that have to do with edge detection, with patterns, texture, and stuff like that. So a lot of it is reused, but then you're kind of mostly playing or learning that top layer to actually be more specific for, let's say, a new breed or more specific breed. So it's that's one way. I mean, there's some other work that's being done to figure out what's the best model for the data set. So if you have a new data set, what would be the closest model you should start with to actually train on that? Some of those that I mentioned earlier, few-shot learning, which is basically you trained on certain types of objects, but then there's a new instance of objects that's very similar to the one before, and you don't want to like train on a million examples. You want to train on few if possible and stuff. So there's like 3 or 4 different directions there that are all under this umbrella of transfer learning, if you will.
So hopefully we'll wrap it up now. And for everyone that joined us, thank you so much. Hopefully you had a chance to listen and kind of hear for those friction points. So maybe those are opportunities for interesting investments in the future. Hopefully you had a sense for where things are going and what you might want to go look at and kind of invest your time in, because there's just so much in the space changing so rapidly. So thank you so much, and I want to thank our panelists. Thank you guys so much for spending the time with us today. Thanks, team.
Just as a follow-up, if you have any question or follow-up, anything you want, you can post in our meetup.